So greetings to everybody. As you know, this is a course on overview of space exploration. The title of this presentation is Archival of Space Science Data Center. So today we are going to hear on India's data repository for Indian Space Science Mission. So it is called Indian Space Science Data Center. Actually, ISDC is a science data gateway to scientists, students like you, various institutes, professors, general public, researchers, principal investigators, and guest observers. So if you want to receive the data from ISDC, so we should know a little bit of data center also. So actually the ISDC is co-located at along with the deep space stations of ISRO, which is that Indian Deep Space Network. So this is that one view where you can see in the center portion, ISDC is located and all deep space stations are here, so that we can receive the data directly from the lunar, interplanetary, and other deep space missions of ISRO directly from the station to the data center. So the main objective of data center is to facilitate data ingestion, processing, archive, and dissemination services for all the space missions of ISRO with a vision listed here. I'll be just touching about a little bit about ISDC as well as the data archive. And actually, the data center was established and operationalized in the year 2008 at IDSN. And till now, there are many missions which have been supported and completed are Chandrayaan-1, AISRO-2, USAT, Megatropics, Mars Orbiter Mission, and NS-2 And the ongoing missions are ASTROSAT, Chandrayaan-2, INS-2B, Bhutan-SAT, Aditya-L1, and ExoSat. There are upcoming missions for which already we are making the data center ready is Chandrayaan-4, LEOPEX, Mars Landing Mission, Venus Orbiter, and other future missions of ISRO. So overall prime functions, if you see data ingestion, the data is downloaded from any of the ground stations, whether it is in India or outside, should be able to ingest the data to our data center, then do an initial level as well as level processing at data center in coordination with the different ISRO centers and other different partners or maybe Indian institutes or foreign institutes, then data archive, maintain the data archive and also disseminate to all the users like you. Then web application hosting, then mission-specific data pipeline. There are a lot of IT components, automations in their services, and application development. Now, another domain which we are venturing into a data science analysis. Definitely, you students, if you are interested, download the data from ISRO and also start doing data science analysis and collaborate with the institute and collaborate with us. So as a part of Indian Space Science Data Center, there are prime functions as I told. In each and every function, there are multiple activities happening. If you see data in there, it's not about the payload data, it is about logs data, reception from all ground stations, like that many things are there. Then processing means quick look display, level 0, level 1, registration, mosaicing, and many such activities. Archival is also data storage, then archival, the long-term archival, active archival as per the international archive standards. Then dissemination. There are policy-based dissemination things are there, initially to payload operation centers and principal investigators. There are cross products and then MTA hosting to then publish. A typical ground segment for you to clearly understand what is actually happening in a ground segment. This is called a space segment where satellites are manufactured. You might have already attended some lectures on a space segment. Now, when space segment is having various sensors, various payloads, various other capabilities, which would be is remote sensing the different like objects and as well as different like intended tasks. And once they receive and when they observe those things, finally it should be downloaded or it should be brought to the ground. So it would be received in ground through antennas. The antenna can be from India, it can be foreign. Then sufficient interfaces and necessary things would be developed and established in such a way that the antenna, whatever data is received, should be sent to a spacecraft control center where the satellite health is maintained, satellite is being controlled and operated. But parallelly, when satellite is healthy, payloads are healthy, everything is healthy, the payload data, which is comparatively larger in volume, is received at Indian Space Center. Here only all the processing will happen and archive would be maintained here. That would be elaborating a little bit more in the subsequent, you can say, slides. And from here, there will be a continuous interaction with mission, where how the mission is getting operated, all the directives and things like that. Now coming to Indian Space Research Center, all the principal investigators, they are the actually people, those who have conceptualized the design of the instruments and payloads. Then payload operation centers, they will do high-level product generations, different outputs generations from the data what is received from the satellite into general. So whatever data is analyzed after doing the peer review, it will be posted at LDC and entire general public can receive this. This is the yellow color box where actually everything will be connected to data center. Now, coming to the standards follow, there are various standards generally are preferred or being recommended for lunar interplanetary missions. One of the most popular is Planet Data Systems, which is being used by almost all the space agencies. And I'll have some few slides on this, which will also dictate about how to structure the data, how to keep the data, and how to transmit the data and associate information. So when we are going to receive the payload data, it is very important for us to understand what is the satellite attitude. Generally, satellite attitude is being stored as a part of the SPICE. It is also an international standard. Now, in addition to that, there are other archival formats, like when we are handling many space missions, there are few missions which are already falling in the interplanetary. There are a few more science missions for which scientific community is not following areas. We have to work out our own archival format, which should be acceptable to. Then there are international standards which are talking about different protocols like planetary data access protocols, and even we are going towards data object identifier and further like that. Then we have to keep all the data sets and associated data at all levels, whether it's a raw data, it's a level process, calibrated data, or there's a high level data formats. And it should be kept in such a way that we should be able to archive, we should be able to access, and we should be able to retrieve it also properly. So for that, we have to prepare a proper structure directly. Now coming to the formats, there are various formats which are acceptable to the, you can say, various scientific community, like PITS. PITS, the flexible image transformation system, which is actually acceptable by all most of the astronomical scientific community. Then HDF5, then next CDF, IMG. IMG is generally used for imaging. Cube is for multi-layer vector payloads. Then DAT file, tab file, TXT, and seeds. So various, you can say, program counters, various X-ray spectrometers, and all those things. They will be providing different types of. So how we decide on archival format? Archival formats are actually being dictated by the scientific community. So our data center is flexible enough to accept any of these type of format and understand it. Now coming to the salient features, to handle the entire science payload data and do a proper management, it is developed and it is established with the high storage management techniques, with the high computation, high bandwidth systems, in-house developed one-way gateway to protect internal archive from the outside layer, and also data skills and enterprise delivery. So this is the picture is shown here, and multi-homing and throughput internet to provide quick data to all of you, and website and applications for accessing the data. Then each and every mission we have to do many other activities, like we have to establish a data pipeline, do a data processing. In a science mission, there is a very important thing is called regeneration, because we have to provide a data to the users which should be very accurate and also complete. So any observations, any lacuna, if we are finding anything during the review process, it needs to be regenerated and need good product should be planned. So in that case, there would be sometimes multiple rounds of regeneration activity also be carried out. So data center should be configured and flexible enough to adopt and to provide such services. Then the data dissemination, as I mentioned, another important thing is a quick look display. So as soon as we have reached to the moon or Mars or any system, so first activity is as soon as data is received, data processing will take some time, but we have to see immediately without much processing, without much corrections, and see whether really we have reached, really the payload is operating in the right mode. The performance of the payload is good. We are pointing towards the right observation source, whether from moon surface, Mars surface, or some of the celestial source. So the quick look display will give us a quick preliminary input and assessment. Then proposed processing system. There are various missions like AstroSync, RFK, and ExoSync. There are science community driven missions. For that, HTC has already developed proposal for the system, and any of the users can submit their proposals and it will be reviewed by the committee and then it will be accepted. The interface with these two stations and 3 layer with the 10 different management. Then finally, the data sharing interface with the acquisition in the stages. This is the way which, if you see, we are generating the whenever any archival structure, what we have to do is any data ingested, generated as whether it's a raw data, level 0, level 1, or file, operation message, and we have to define the file name, format, naming conventions. These are very important to give us a information how, what type of data and what way it is going to come to us. And it would be monitored by our own file transfer services and then define the storage area. Here it should be kept based on the mandate and based on the type of data sets. There will be different paths to be defined, which would be daily monitored and 70 minutes would be done by our storage management. Then there are transfer paths. Now this data, once it has been generated, has to go for internal consumption as a part of different level of processing. It would be defined by, and it will be kept into a transfer path by the players and also by the different level of processing from players or applications. Then finally, whatever outputs are generated or whatever files have been provided should be archived. It is also monitored here. Then define the retention period. Once data sets are kept for each and every area, whether it's a temporary area, whether it's a long-term area, whether it's software, library, execute data product, the retention periods are defined and it is monitored by our storage service. Then apply the data policy, data backup policy, which should be taken care by our storage services, and regular verification also will happen and verify the internet pipeline by peers. These all elements are totally monitored on active basis. So, you know, as a student, when you are maintaining an archive, there are many things that are happening in the cloud. So, and when you are going to receive the data at your level, you can say. So, for that, we are giving data to payload operation centers where high data product generation is also carried. So, data product generation and then archive compliance check as per the standard would be done. Then the review would be carried out so that it would ensure that data, whatever is going to be released or provided to the users, it should be complete, correct, and all things. So then accurate data, whatever has come, it in the quality check and verification will be performed and handled over the quality check and cleared the data to us. Then after the lock-in period, because some missions there is a lock-in period initially, but slowly that lock-in period will go off, like for Chandrayaan 2. Now there is no lock-in period as soon as it has come in disseminated to the users. Then IGC releases the data and updates the long-term archive and data access to include all elements will be done. During this process, if any lacuna or anything which is being recommended by the scientific community during the peer-review process, it will be regenerated entire product and then only the accurate and complete set will be followed. In addition to that, data archive management, these are the storage level things which students can go through. So whenever there are processing elements, these are all processing and access elements. Whenever high performance is required, and in a top level, the SAN environment is required, which is coming from the storage area network, where it is high performance and storage is connected. The data can be fetched here, processed, archive can be maintained and kept back here. And regularly there is a backup is happening in the it is in enterprise cluster. And we have multiple type of storages. Whenever the medium performance is required for the storage, it is kept here. But finally, from here to here, it is being synced for the data safety purpose. This is just a typical glimpse that when the file is generated here, when the data is generated here, it will come to the primary storage. Then it will go to the secondary storage, and one copy will come to the LTSS, another LTSS, 2 copies of the backup. And then every month we are taking a world copy, which is kept in data save separately. Various computing environments are provided as a part of data processing equipment. As a student, as a user, you should know that there are a lot of science data alliances out there. One of them is very important is APDA. But why science data alliance is required? Because various national and international agencies, we are taking proactive interest in standardizing the data sharing formats. For example, like one agency is giving one data in X format, another is giving in Y format. Then in long term, every agency will start giving in a number of formats and different type of assets in the same data in a different format. So as a user, it would be very difficult for me to utilize my software or tools to interpret or to use that data, because the data formats are keep on changing. So foremost thing is we all have to sit together, whether it is a national, international level, for each type of missions, like the lunar, interplanetary, astronomy, or the helio, or the those type of missions, even exoplanet missions. So there would be a unanimous consensus on the data, so which is being developed together. And another very important thing is science data should be kept for a longer period into the perpetual. It is always having a high value, even when new missions are coming. So we have to keep on ensuring that data should be useful and user-friendly, and access tools should be provided along with the data. And it should be flexible and interoperable, but it can use in different environments also. So one, as I have told you, interplanetary data. IPD, it actually works on developing international standard and common methods for connecting and describing the planetary science data across the international community. ISRO is also part of that. And there is another very important data alliance, which is actually very aggressively it is working now. It is the International Heliocentric Data Alliance. They are talking about the heliocentric data. So they have put on their website many data formats which should be acceptable. Metadata also should be kept in standard format. Just like that, it should not keep in some non-standard, so that it should not create any difficulty for users to interpret, as well as for these tools should be able to understand this metadata and data also. There are various tools and APIs. Now coming to the ISRO Science Data Archive. ISRO has hosted our own Science Data Archive. The URL is here, ishtc.org. When you go to the ISDA page, you will find some text here. On ISDA, what else is there? As a lunar, Chandrayaan 1, Chandrayaan 2, these two datasets are already posted, and very soon you will be seeing Chandrayaan 3 data also. Peer process is getting completed, and very soon you will see Chandrayaan data also posted in the ISDA website. Coming to astronomy, AstroSat data is already posted. ExpoSat will be posted soon, and heliophysics, it is under already giving a lot of data sets. So once this initial level processing and the reviews and the is over, this data will be posted here. Interplanetary missions, marks of the mission already posted here. There is another mission is CREST. It's more on geostationary, the radiation, I can say, spectrum. That data is also hosted. Okay, the data is website. ISRO Science Data Archive. So these all kits are there. Very soon, the grid or Chandrayaan 3 other ExpoSat also will be provided for accessing the space-based data. As I was telling about data, so PDS is the most important thing, which as a student you should know. It is for long-term preservation of the data. It maintains the visibility and facilitate the scientific community with high quality of data for them. For example, today you have got some data in X, and you may be using some Windows system or maybe some Linux system. In future, the version of that Windows, the version of that Linux, the tools which you are using in this Windows and Linux or Mac, they may be changed because the OS version is changed, new tools have come. So how to use that science data in the new versions of OS, new versions of tools, it should be compatible. So we have to ensure that long-term preservation and usability of the data. So for that, what we do, we have to maintain a proper structure there. The Chandrayaan 2 bundle, normal operation phase, instrument kernels, and everything will be. If you want more on this particular thing, you can visit this website on this website. So what it will maintain is, it will actually comprise of various levels of data, and there are two types of, if you see structure, two types of data sets. One is like browse data and geometry, which is keep on growing, like Chandrayaan 2 mission, AstroSat mission, they're already supplying data companies there. So this area will keep on growing. Your DT, MMYY things will be keep on growing as soon as we keep on releasing. But there are other areas like context, calibration files, XML files, XML schema, and document. How to understand these data? All those things are one-time data sets. They may not go for each and every dump for each and every day or each and every day. We fix. So these are the continuous going. These are fixed. Along with that, each and every data can be kept in a different format. It accepts IMG, Q, date, CSV, all these formats. Okay. So this only I was telling one-time data, and the separate downloadable table files are kept in the ISD structure. Okay. And data is provided with various options for browsing and download. You can download a single file or you can download the multiple files. This is the structure which I was telling. So parent directory, the mission name, then product level, and payload wise, and then BO wise and one. Right. So as I told at the time, like archival formats are science and remote sensing driven and based on wide acceptance by the analyst. So one example I'll give about Chandrayaan. So Chandrayaan, if you see that first time data was released in 2021. These are the data sets which are already released, available there. Huge amount of data is around 20 terabyte of Chandrayaan. As of around 28 terabyte of data is registered. Till now, 4,900 users are registered. These are the website. You can note down and it just shows the details of that. So it is accessible via web-based access. To access, what you have to do is you have to open the URL given here, log in. There are other features. If you have already logged in, you can reset your password or you can import your password. Then once you have successfully logged in, payload, you can select, go to browse and download section. You have various options of filter, search the results based on various parameters. You can view the metadata, you can see the file size and select the data download. You can integrate with the download manager also. There are various user guides, tools, calibrations, and the structure is also available as a separate file under the under download section. And then most important, remember, you are utilizing the data for any publications or any of these, there are acknowledgement statements out there. And you can refer the disclaimer and FAQs are also provided. So I'll just give you a small demo of this. If you go to ISDC website where you are going to get entire science data free of cost. So earlier what happened when you want to do something, you have an idea, but you don't have a data. Now you see the science data is available to you. You can definitely access this from going to the LGC website, clicking on suppose Chandrayaan 2, or from here also mission Chandrayaan 2, click on this, you will be on Chandrayaan 2 page. Once you go to Chandrayaan 2, there are various information, whether it's to payload, brochure, poster, papers, everything is available. You have to click on data grid, click on access. Once you click on access, it will ask you to open a new window. It will take you to the Pradhan. Now this is the Pradhan website. You have to click on login. Here various features are there for Pradhan. Once you click on this login, you will be logged. If you are a new user, first time you click on register. If you have already registered, click on the forget password. After successful login, you will be logged in here, and these are the information which you can ask for. You can say changing the password, or maybe you can edit your account details. Click on this browse and download. Various clicks are displayed here. If you go there, if I click on suppose class, as soon as I click on the class, my entire data set is appeared here. The first thing which as a user you have to see is user manual. If you don't know how to interpret the data, so user manuals are available here. Once you have downloaded the user manual, next thing is downloading the data. For different payloads, there are different type of metadata. So we have given here, like for class, file name, observation, and system coordinates. Even if we go here for IIRS, there are various exposure level, gain level, even the altitude level also, you can filter the data product. For TMC, you say imaging orbits, wind direction, exposure, and corner coordinates also, coordinates. You can filter the data set. So once you select this one, and you can add any combination of, you can add one, then again you can add one more here, you see plus minus. You can add 1, 2, 3, observation, find and find. Any combination of filters, give the value and click on search. Once you click on search, corresponding data sets will get filtered out and only the relevant would be available to you. Now one more, once the relevant fields are available to you, we have given by default some columns, but if you want to increase or decrease the columns, there are options here. If you click on this column, you see for this, when I have clicked on these columns, already there are two more things are not there, but these things are already selected. But there are other payloads. There are various other parameters or columns. You can select, click on OK. It will come here and submit. So everything will get displayed here. That will give more information to you even before downloading the project. Now, sometimes I don't know what type of, or as a user, I don't know what type of network I have. Whether I can download the large volume file or maybe small volume file, or how much time it will take. So in that case, I can do one assessment. I can For this particular data point, suppose there are file size info. I can click on this particular file size or info. If I click on info, metadata is available here. This is a glimpse of the metadata. This is the PDF label and this is the XML. Both will give you the all information related to the payload before downloading. Another very important feature is I can show and see more data products into a window field. And another thing is, if I want to download multiple data, you can click and click from here and download. So here, if I click, entire thing gets selected. And if I click on this, you get another. Another feature is I don't want to select by myself. Since I have taken a very small, very unique case of class data sets are completely small in size. So I can download so many data sets bundled together. So that feature also is provided. So if I say select from 185 up to 10 MB size, click on select. As soon as I click on the select, it will do it 185. Automatically click select up to 639. Based on the file size, it will keep on computing the file size. So up to this file set, you can say that up to 10 MB data, I can download. So once I click on this, entire data will get downloaded. So it is like a bulk download feature of the data. In addition to that, as I told you, when I download the data, I have to maintain in the PDF structure. So it is only data, whatever I mentioned about that data content. Now there is a static content. So how the structure to be maintained? Go to the other download section, click on ISD emission bundle, and download the entire zip. In addition to, if you want to understand more PDF code here, click on this PDF code, all the details will come. Even the tools are available here. These are the tools which can get downloaded. You can download, you can open it data sets using the PDF code. Now, in that case, like how it should be kept in the data structure. There are some IIRS example I have got IIRS.zip. If you see the entire browse, bundle, calibration, data, document, the entire data sets will get downloaded if you unzip it. Only thing data is black. Data is means whenever you are downloading into data, that data you have to keep that is remaining everything that structure is maintained. This will help us in creating the PDF structure into the system also. Now clicking on other downloads, these are the various things which are provided for each and every payload, each and every information from the end tools, documents. If you see various missions, if you go there, you see doctors are also being put. README files also are being put and user management. So you can download and then access it. For each and every payload, there are user manuals. If you go line by line, you'll be able to understand and interpret the data. You can also see the history and statistics, what all things you have downloaded in recent, what all things. Now, most important as a student, you will have a lot of doubts. You see about the data, how to interpret and how to access that data. So there are already known FAQs we have put into our website from here, common FAQs with respect to data download and all those things. Then there are data FAQs with respect to each and every payload. If you go through that, most of their questions would be answered. You'll get more clarity. And in fact, after that, if you feel like further I want to interact with us in contact, we have given a direct email IDs of all the concerned people. You can access, you can just reach out to them and take their help. In addition to that, whenever you are publishing any paper or something, there are management statement that you use. And if data-wise, if anything is there which you should know, then that is already mentioned as a part of disclaimer. So another thing is when you go to the web-based access, there are user guides, 5-meter terms, and there is a map browse is also available. So map browse is which type of map browse will come. Because many users, they are more restricted to access or download data based on the map search. In that case, we have given this tool also. The entire data sets would be listed there as a part of on a map at a different layer of the strip. If you select like IIRS and this one tick, and this only would be shown. If you select all, everything would be shown here. And then if I just select a particular 2-3 lines, so those things will come here. Here you see listed down, and it will. If I click on this with my mark or select this, on that purpose, we click on download. Once we click on download, it will get download. One more thing we have done here is when you go to that this one, recently Chandrayaan 1 also TMC ISRO is also added. So it will also be visible here as a different color. Now coming to Chandrayaan 1, there are some 11 payloads. Some of the images of mode, which if you want to download and analyze, it is available here on our channel. As of now, there are 1807 plus users and more than 18,000 downloads are there. In Chandrayaan 2, I have told you that more than 4,900 users and 20,000. 20 terabyte data is hosted here. So you can go there. Even the Chandrayaan 1 Atlas is available, TNC data is there, your payloads are there, gems are available 25 and 10 meters, alumni, MIP, radon, like many things are there, and then web-based view is also available. In addition to that, this is the image which is of a crater called Sarabhai crater, the 3D view, and it is named after, father of Indian Space Program, Dr. Sarabhai. So it is already available on, and these are the high resolution images provided by HRC. Is 1 to 2 meter boulders also you able to see this much small, which was not at all possible earlier before Chandrayaan 2. These are the dual frequency SAR, which is already doing image into animals planet. Now coming to the astroset, which is called as a dedicated multi-wavelength space observatory. It is having various payloads and giving very good information with respect to the you can say the universe. So in the one comparison which is recently from this website as well, is the resolution from astrosat in comparison to the galaxy telescope earlier. The new population point of stars is there in spiral galaxy which proves. So all these data sets, what you can do is you go to the astrosat page, click on data access, and here an extra browse. Log in here, or register yourself, and log in here will be landed to this particular page. Click on search astrosat handbook and other software also available. If you click on handbook will come, you can go through that. Click on search, type the object in rectangular, automatically you go there, resolve by symbol, it will get resolved. It's already connected to the internet. The position and the date will be automatically get resolved. You need to remember that. Then click on all payloads. If you want only 1 or 2 payloads, you can remove this, or if you want all ticket, then click on search. Once you search on there, you will get the entire list of the products. Now, if you want to download, see here quality level 1, level 2. So if I click on a particular data product, we can download it here and we can download. Okay, the name of the data product also will come here. Very important thing here is another allergen field. So when you click on this data allergen field will come. So there is called SkyMap. If you click on this same data product or that source, it is here in the view you can see. And if you click on the product details, the entire product will also be visible. So you can, even before downloading, you can go through all those things. If it's really it is finding good for you as per your area of interest, then you go ahead. In addition to that, I want to see what where is the product source. What I can do, click on this, resolve another view. Immediately this particular another views will give me the position of this one and RA of this particular. Same RA also I can go to the search and just go there and put all my data, put the big balls. There are a lot of software tools are also available here. You can download into the system, download the data, and start analyzing it. Any further help is required for you, then you can use this one. One second. So now you can, if you want further on this, there are tools available, and you can contact here for further help from. Now coming to Mars observation. Here are all the typical data pipeline of the past data was released by your chairman and photographs taken during while it's voyage to Mars. First would be next number. So this you see the cloud and so all fantastic products are available on our website. If you go to biology photography, go to the Mars information, and then you will have this particular portal where you can see the based search and the table based search. Both are there. Then we complete it, then on for it to register. Select the product and click on download. So this type of things are there. But download. Now you know that Aditya and Exposite missions are going on and on. And there is no could be and these two missions also would be made available to our executive portal by Archival. Refer whatever you have shown that and the option. With that, we have completed the brief and demonstration of the Space Science Archival of the Space Center for ISRO. Thank you.